Here are a few more examples on the parabola. Okay, so notice that in our very first problem here, we do have it in standard form because we have our squared term isolated by itself. And so because it's in standard form, we can already go ahead and start identifying all the pieces that are going to help us actually graph. So notice that the value that's inside the parentheses with the y is going to be the second value of our ordered pair for our vertex. Whatever's in parentheses with the x is going to be the first number in the ordered pair for our vertex. But remember, our vertex has to have those numbers, the signs have to switch. So really, it's going to be 1, -1 for the vertex. To help us find our focus and our directrix, we have to understand, one, what direction is my graph going to be opening? Is it going to be opening up or down? Is it going to be opening left or right? And then by understanding that, we can then figure out what kind of line we're going to have, whether it's horizontal or vertical, and then where our point goes. So we look at the number that is in front of the non-squared term, and that number we want to set equal to 4p. All right, so in this case, 4p equals 4, so that means that our p value, when I divide both sides by 4, is +1. And so because my graph it has a y squared equals, so y squared means that my graph is going to be opening either left or right. And because my p-value is positive, that means that my graph is going to have to open to the right. Okay, so anytime it's positive, it's either to the right or it's up. Anytime it's negative p, then it's going to be left or down. And hopefully you remember that, like back in the day, we always were solving and graphing equations that were like y equals x squared. And so remember, that tells us that we were opening up or down. So when the x is being squared, it opens up or down. So that's why when it's the y that's being squared, it opens left or right. Okay, so now because I know that my graph is going to open right, so it has to look something like this, I know that my focus point has to be a point that is inside of that parabola, and my directrix has to be a line that is not going to intersect that parabola, which means that the only type of line that won't intersect it is going to have to be a vertical line. So to find the focus points, I know that if my vertex is going to be like somewhere here on my parabola, it's going to have to line up nicely, and in this case, horizontally with the vertex point. So if my vertex is 1, -1, my p-value is going to be the distance between my vertex and my focus, and then my vertex and my directrix. So since p is 1, that means that because it's lined up horizontally, I'm going to have to add 1 so I can go to the right onto the first value of my vertex. So 2, -1 is going to be that focus point. And then if 1, -1 is my vertex, I have to move to the left 1 in order to create that vertical line. Anytime we're talking about a vertical line, it's going to be an x equals equation. And so if, once again, my vertex, the first number in my vertex is 1, and I need to move to the left of that 1, well, 1 -1 tells us that x equals 0 is going to be the line where my directrix is located. To find the length of the lattice rectum, it is going to be the number that is in front of the non-squared term, but it's always the absolute value of that. In this case, taking the absolute value of a positive number is a positive number, so it's 4. Okay, so if I plot my points, so we've got 1, -1, so here's my vertex. We've got 2, -1, so once again, notice that it's nice lined up horizontally, and then my directrix is on the y-axis because it's x equals 0. Okay, remember, I want to have a couple more points on my parabola. So if I know it has to open to the right, this length of the lattice rectum is really going to help me figure out where the other 2 points that I want in my parabola are. You have to go from the focus point, and now in this case, because we are opening to the right, that means that I'm going to have a point that's above the focus and below it to then create that shape. And so since the length is 4, that means that I'm going to split that in half. So from the focus point, I'm going to go up 2 and plot my point. And from the focus point, I'm going to go down 2 and plot my point. So notice that this right here, that is a length of 4. That is going to be the length of the lattice rectum. Okay, so that's why I split it in half. So now connect the points from that vertex to the point that is creating the length of the lattice rectum. And there is the rest of my parabola. Okay, if I'm looking at this next example, notice that it is not in standard form. So the first thing we're going to do is we are going to have to complete the square in order to get into standard form. So I see that I've got my y term that's being squared. So I'm going to keep the y terms on the left. So I'm going to have y squared minus 2y. But then I got to move anything that doesn't have a y over then to the right. So I'm going to take that negative 2x. I'm going to add it over to the other side. So that makes it positive. Okay, so I'm adding 2x over to the other side. And then the negative 5, I'm going to move to the other side. And that also gets moved over by adding. Okay, so now I want to complete the square. So in order to turn the left side into a factorable polynomial, I'm going to take my negative 2, I'm going to divide by 2, and I'm going to square it. Well, negative 2 divided by 2 is negative 1. Negative 1 quantity squared is 1. So we've got y squared minus 2y plus 1, and that equals 2x plus 5. But now because I added 1 onto the left, I have to add 1 onto the right. So notice that when I then factor now the left-hand side, what multiplies to 1 but adds to negative 2? Well, negative 1 times negative 1 multiplies to positive 1 and adds to negative 2. So it's y minus 1 quantity squared. Over here on the right, I combine like terms and I'll have 2x plus 6. That's not my standard form though, because the right-hand side also has to be factored out. Any GCF needs to be taken out. So my standard form equation is now going to be y minus 1 quantity squared equals, what does 2x and 6 have in common? Well, they have a 2 in common. So that leaves us with x plus 3 left over in parentheses. There's my standard form. Okay, so then identifying the vertex, remember the number that is in with the y is my k value, the number that's in with my x is my h value, but I changed the signs. So it'll be negative 3, positive 1 for my vertex. Once again, just like the last example, the y term is squared, and so that indicates that we are going to be opening either left or right. Looking at the number that is in front of the non-squared term, 2p has to equal, or sorry, not 2p, 4p has to equal that number. So it has to equal 2. So then to get p by itself, I'm going to divide both sides by 4. And so this time my p value, while it's positive, it's a fraction. So p is a half. Okay, but it's positive. So because my graph has to open either left or right, but p is positive, that tells me that my graph, once again, is going to be opening to the right. And so that means that if my graph has to open to the right, the focus point has to be inside of that. I need my directrix to be a line that will not intersect. So it is, once again, another vertical line. So my focus point is going to be, if my vertex is here, it's going to be a half to the right of that vertex. So negative 3, if I add on a half, that will move it to the right. So negative 3 plus a half will be negative 2.5, but the y value is the same because they need to line up horizontally. My directrix, since it's a vertical line, is x equals. So from negative 3, now I'm moving to the left a half. So to the half to the left of negative 3 would then be negative 3.5. Okay, the length of the lattice rectum, once again, is the absolute value of the number that is in front of the non-squared term. So the absolute value of 2 is 2. All right, so now I have enough information to then start graphing. So I'm going to make each of these, so let's see. So each of these now is going up by ones, but it's technically going up by half. Okay, so there's my indication of what my axes look like. So negative 3, 1, that puts my vertex right here. Okay, if my focus is negative 2.5, 1, that puts it right here. My directrix is a vertical line at negative 3.5. Okay, and then since the length of my lattice rectum is 2, that means from the focus point, I want to split that in half. So that means I go up 1 and I go down 1. That creates the length of the lattice rectum, and then I can connect my points from the vertex to those points that created the length of the lattice rectum. And there's my graph. Okay, finally, the last one here. Let's write an equation in standard form given the focus and the directrix. Okay, so if I'm given the focus and the directrix, that means that we're going to be able to figure out the vertex because the vertex is going to be halfway in between. Notice that my directrix is a vertical line. It says x equals. So that means that my graph is going to be opening either to the left or to the right. If this is where 8 is, negative 2, 6, if I think about that, negative 2, 6, that's going to be to the left of that line. Okay, so if we think about like our like if this is 2, 4, 6, if this is 8, and that's where that line is right here, negative 2 would be over here, and then 6 would be like 2, 4, 6 up here. So notice that my focus point is to the left of my vertex. Okay, so that means that my graph is going to open to the left. And so that tells us that our p-value is going to have to be negative. So keep that in mind. Okay, but think about this. If negative 2 is right here and 8 is over there, remember, it's halfway in between where my vertex is going to be. So what's halfway between negative 2 and 8? Well, technically, that's a length of 10 right there. Halfway would be 5. So if I go 5 to the left of 8, so 2, 4, 5, right here at 3, that's the halfway point. Okay, your focus point and your vertex are always going to be lined up nicely. So in this case, because my graph is going to be opening to the left, I know that my focus point and my vertex are going to be lined up horizontally. So that means that it has to still be lined up here. And so that means that my vertex is going to be the ordered pair of 3, 6. Okay, and so I know that my y term is what's going to have to be squared. So I know it's going to be y minus 6 quantity squared equals, it's going to be some number, and then it's going to be x minus 3. Okay, so we just have to figure out what that number is. And so remember, our p-value is going to be the distance between the vertex and the focus, or the vertex and the directrix. So what's the distance between these? Well, we said that that was a length of 5. So that means that if my p-value is 5, that means that this right here is 4 times p. So 4 times 5 is 20, but like I said, because we're opening to the left, it has to be a negative. But this would be my equation.